rather avoid. Personally, I would rather avoid this repetition, especially with just the is to reference the standard namespace. The string class is written in the string header file, but specifically within the standard namespace in that header file. So we write std string to let the compiler know that the string identifier can be found inside the standard namespace. If we wanted to print this string to the screen using the object cout, we would have to do the same sort of process. Step 1, include the iostream header file, as that's where cout is located. Step 2, reference std::cout so the compiler knows where to find the cout object. As our code grows, we may find ourselves writing std::, over and over again in our code. Some may prefer this as it makes the code a bit more explicit. Personally, I would rather avoid this repetition, especially with just the standard namespace. There's a keyword called using that will help us avoid this repetition, and we put it at the top of our files after the #include directives. This line of code tells the compiler that cout is a thing that exists in the standard namespace. Because we're using the using keyword to reference cout at the top of our file, we don't have to write std::, in front of it. This can clean our code up a bit, and if we make use of the using keyword at the start, we can write the rest of our code a little bit faster. Let's see what our code looks like if we do this for other identifiers as well. If we have a using std::, statement for all the identifiers we want to use, it can simplify the rest of our code quite a bit. Now, there are a lot of classes in C++, and this can end up getting kind of cluttered in and of itself. There's a simpler way to get all of this functionality with one line of code. We can bring in an entire namespace with this approach. This line of code says use all the identifiers that are found in the standard namespace. Now, we don't have to write individual using statements for each and every identifier that we want to use in our code. Throughout this semester, you can and should do this in your code because it greatly simplifies things. However, in a very large project, this could cause some issues with code collisions. So let's say we have a hypothetical namespace cleverly titled My Custom Namespace. And in this namespace, we have a custom class called string. Now, let's say we have some code that #includes the string header to clarify things, my custom namespace. And in this namespace, we have a custom class called string. Now, let's say we have some code that #includes the string header file, and we use the using shortcut to bring in the standard namespace as well as everything in our custom namespace. So far, so good. This doesn't cause any problems in and of itself. Next, let's say we wanted to create two different string objects, one from our namespace and one from the standard namespace. To do this the longer way, we would specify the namespace for each of these. Still okay? No problems with this code. On this line of code, we're going to run into some problems. We didn't have to specify the namespace because of the using statements that we put in previously. As a result, the compiler doesn't know what to do here. It knows about two identifiers, both of which are called string. So we'll get a compiler error due to ambiguity in this code. Now, this is a contrived example, and in practice, you probably wouldn't call your own class string due to C++ already having one with that name already. However, there are only so many names we can use for some things, and the best names might be reused by different people, especially if we have a lot of people working on the same project. We won't really run into this issue in this course, but you should at least be aware of the possibility, especially if you find yourself working on large projects with lots of people and lots of different systems come into contact with one another. So all that talk of namespaces was a little bit of a detour, so let's bring it back to the last type of scope we'll cover, the global scope. This is where things can get messy if we're not careful. What might seem like a good idea at first can really end up biting us later on. Global scope is the broadest scope in C++, and something declared outside any other scope will default to global scope. Because global scope is the broadest, variables in this scope can be accessed and modified anywhere in our code. The lifetime of a global variable is essentially forever with regards to your program. Globals only fall out of scope once the program ends. Now, in this small example, the message variable is declared as a global variable. This means we can access it inside the main function, something we normally couldn't do if the variable were in another scope. This example is pretty harmless, but let's look at another one. So let's say we have this example here. We want to store and print the name of the greatest song of this century. If you pause to think about this for just a moment, you'll see that I'm right. Moving on, our code in main seems pretty straightforward. Call this foo function and then print out the name of the song. But what does the foo function do in this case? Now, because the variable is a global, it's in global scope, it can be modified anywhere in our code. If, for some reason, this function made a change to the value of our string, the final output of our program would be different than what we expected. Because globals can be accessed anywhere, they often seem easier to use, especially for new programmers. However, if something is easy to use, it's also easy to misuse. It takes discipline and effort to learn the proper ways to do things. In this class, you should avoid global variables completely. Instead, you should learn the proper way to use functions and declare variables exactly where they're needed. Now, all of this here is a made-up example, but depending on how our code is structured, we might have code somewhere that changes variables in unexpected ways, and we want to try and minimize that. So scope deals with how we can access parts of our code. Variables can exist in very limited, narrow scopes, or all broad, of this here is a made-up global scopes. We need to learn where to best declare our variables and functions to make sure we can access them, but also make sure we restrict access whenever possible to avoid accidental changes. Namespaces are something that can help us organize our code as well by letting us break it into groupings of variables and functions. C++ has the standard namespace, which contains a great deal of functionality in it. We'll look at lots of that functionality over the course of the semester. And that wraps things up for this video about scope. In this video, we're going to look at writing Hello World in C++. Hello World is the simplest kind of program, the thing we tend to learn first when we're learning any new language, and all it really does is print out Hello World to the screen. It's the simplest kind of program, and then we build upon that and learn new language features and so on and so forth. So depending on your background, you may have already seen something like this in Java, you may have seen something like this in Python, or possibly in C or C++ if you have experience with that. If that's the case, then most of this video will be old news to you. So every language has their own style, every language has their own sort of structure to it, much like human languages. The way we speak English versus the way we might speak German or Japanese is potentially very different. They're not all constructed the same. They don't have the same rules. Occasionally, there is some overlap, and we can kind of apply some knowledge that we have for one language to another. But sometimes we just have to learn the new rules, and there really is no equivalent. In which case, well, that's just what we need to remember about that language. So there will be some similarities, but going forward throughout this semester, there will
What up, YouTube? Welcome back to my channel, you guys. If you learn more before we, let's say you want to go ahead and create the project. So you have file. Okay, so let's say new. Let's say you say new file, and you want it to be a C++ file. Okay, so go write this code up real quick. Alright, so as you guys can see, it's not saying anything in my code, so we can go ahead and run it. And see this error right here, unable to start program. The system cannot find the file specified. Okay, so for one, you got to make sure there's no errors in your code. Like right here. For one, you want to make it int main to get rid of that. So that looks good, right? So there's no errors, as we can see. There's nothing really going on. So we go ahead and try running it again. It says that again. So errors. So once you guys realize there's no errors, what you actually want to do is, I'm going to copy this code. You want it on the right side over here where it says Solution Explorer. You actually want want to open up a file in here, I recommend you guys using the source files. It's just a good habit to have, but I'm not here for habit building for you guys. So if you guys want to put it in the resources or header files, it's up to you. But I personally would put it in the source files. So go ahead and just right click on source files, hit add, do new item. You want to make it a C++ file, and then you can go ahead and copy and paste it over here actually. And then you see how there's an error right here. So if you didn't even add it over here, you couldn't even tell where the errors are coming from. But there's an error in the cout. It's because we're actually missing a library that we're supposed to have. All right, so now we have no errors. Um,
just be some new things that we have to learn, especially if you're coming from a language that doesn't have an equivalent. So I'll close these for now because we don't really need to look at those anymore. But let's take a look at the starting point of our program. We'll look at these 2 lines in just a minute here, but let's start with main. So main is the entry point of our program, and it's the main function of our program. Now, depending on what your previous programming experience is, you may have heard the term method before, especially if you're coming from a Java background. So Java will call them methods. C++ will call those functions. Python will call them functions as well. Although both of those languages, C++ and Python, will sometimes make reference to the name function or method. Generally speaking, a method is part of a class, which is another concept we'll get to later on. But in Java, everything is a class, so everything is a method. In C++, we'll use functions or member functions if we're talking about classes. So I'll use that term for everything in this semester. If you use the word method, I'll understand what you're talking about. I won't think you're crazy. If I use the term functions, hopefully you'll understand what I'm talking about and won't think I'm crazy. So the main function returns an integer when it's done. It returns some numeric value. That's what we have right here, some return type. And the default return of main should be 0. If everything goes okay, you should return 0. And so we can just think of 0 as meaning 0 errors. Nothing has gone wrong with our program, and everything is okay. If something did go wrong with our program, we might sometimes return something else, maybe -5 or 100 or some sort of number to indicate a bad thing happened. But generally, we hopefully want to return 0 because everything is okay. So that aside, the layout of main is such that it returns an integer and it accepts no arguments in this particular format. We might sometimes see another version of main that looks similar to this that we would see in Java, where it accepts some array of strings, an array of arguments. We'll talk about that a little bit more later on in the semester. For now, we don't need to worry about that. We can have a version of main that accepts no arguments and is empty. Sometimes you might see this written as void, where there are no parameters. This is an empty parameter list, but we can just omit the void and simplify things a little bit there. Now, depending on your programming background, this might look a little bit weird to you, the presence of these curly braces here, and especially if you're coming from a Python background where we don't encapsulate things with braces. We also don't use semicolons to end statements, so that will be a little bit of a change if you're coming from a Python background. If you're coming from a Java background, which is also part of the C family of languages along with C++, then this will all be pretty familiar to you. But all of our functions must be encapsulated with braces. So this is all kind of lumped together here. Now, once we have this set up here, what we're going to do now is talk about these statements here. So we have this very first line, this pound include statement, and then we have something called IO stream. So this is just the name of a file. We have a file that's part of C++ called IO stream, and there are many files that will end up including like this. We've got one called vector, which we'll look at a little later on in another video. We've got string that we'll look at a little later on. We'll include lots and lots of these various C++ files. We might sometimes also see something like this, where we include something like a file that we write, and this is some custom file, some of our own information that we want to bring into our program. I'm going to get an error in this case because my program knows nothing of this file here. So let's bring that back to IO stream, and we'll talk about some of these things a little bit more later on, but now we're just talking about hello world, really. And this line right here is kind of optional. Well, it's not kind of optional, it is optional, but depending on how we write our code, we might include this or not, but we essentially need to make use of some stuff in here. Now, namespaces go a little bit beyond the scope of this particular video, but essentially it's bringing in some other functionality from elsewhere that's wrapped up in something called the standard namespace. So we'll look at why we might need this line and how we can also work around it. So if we want to get to the actual hello world part, we'll just write this line of code here. We'll write something called cout, and which that's what that is. That is cout, not one word pronounced as count, but just cout. And then we'll write hello world. Oops, and then we'll end that right there. So what this is doing is cout is going to take some information that we provided and put it into something called an output stream. This is basically where some data can be transferred to some other destination. By default, this is going to be a window, a small console window, and this will just print out some messages. This goes beyond the scope of this particular video, but we can also, read this stream data through other programs and things like that, but we're not going to worry about that now. So this little symbol right here, this is called the insertion operator. What we're doing is taking this information here and we are inserting it into this stream of data. So this little symbol here is called the insertion operator. And we can use this to send data to the output stream. Then after hello world, I'm going to send something else to the output stream. This little keyword here, endl, is going to print out a new line character. Now you may have also seen new line characters as something like this with this \n, but that's just going to print a new line character. So if we were to print out hello world twice, then this would print out hello world, essentially hitting return or enter, and on the next line printing hello world a second time with that \n character. And so if we were to run our program now, then we would see exactly what we would expect is just hello world printed out to our output window. Now, because I'm running this in an IDE called Visual Studio, I'm also going to get this message at the end here that says, you know, my whole process exited with code 0, and also press any key to close this window. I don't have that information in my code anywhere. This is something that Visual Studio will sort of inject into this process because it's taking my program and it's running it as kind of a sub-process of this window. But this is my program right here, which just prints hello world, right? So that's the basic idea behind hello world in C++. If we wanted to get more advanced than this, of course, we certainly can, and we will throughout the rest of this semester, but this is your basic output program here. Now, the last thing before I forget, I said I would mention this, is this line of code right here, this using namespace standard. Now, if I take this out, my code won't compile, and the reason why is because my code doesn't know what cout is. It also doesn't know what endl is. And so in order to use those, I would write std for the standard namespace, and then I would use these 2 colon symbols right here. This is something called the scope resolution operator. And so we have std, which is the standard namespace. Then we have the double colon, which is the scope resolution operator. We'll talk a little bit more about a lot of these things later on throughout the semester, but that essentially says this thing belongs to this. The scope resolution operator kind of indicates ownership here, so cout is part of the standard namespace. Endl also is part of the standard namespace, so we can do that. Now, if I don't want to write this over and over and over again, I might say, you know what, let's do using namespace standard. So now anywhere in my code that I reference cout, for example, if I did something like this, because of this line right here, this symbol is understood. And so you might see this code written in 2 different ways, in both of these ways, depending on who you're working with, what code you happen to come across. I tend to prefer something like this, especially for these basic symbols here, but some people might prefer this style. So it's essentially the same thing. And we'll talk a little bit more about namespaces later on. All right. So that wraps it up for this video. Just a basic look at writing hello world in C++. Like all things programming, even a simple program. In this video, we're going to look at some basic C++ functionality that's a little bit more complex than a basic hello world program, but is still relatively simple in the grand scheme of things. We'll look at some basic features that you're likely to write or see in a variety of programs, and we'll talk a little bit about some things you might want to keep in mind when you're writing code, whether that's in C++ or really any language. So let's say we were tasked with something simple like this. We need to get some user input for a couple of numeric values and then add up all those values and determine if the sum is positive or negative. This is a pretty simple task in just about any programming language, but let's see how we can do that in C++. So the first thing that we need to do is create an array of numbers. So in C++, we would declare our data type here. So I'm going to make this an array of integers. I'm going to call this numbers, and then we give it a size. If the sum is positive or negative. This is a pretty simple task in just about any programming language, but let's see how we can do that in C++. So the first thing that we need to do is create an array of numbers. So in C++, we would declare our data type here. So I'm going to make this an array of integers. I'm going to call this numbers, and then we give it a size in brackets here. So we could make this size 3 or 4 or 400 if we wanted to, but let's just say we make this a size of 3. So after that, what we're going to have to do is actually get our user input. So the way we handle user input in C++ is with a variable called cin. So much like the way that we would print values to the screen using cout, and then we use some operator. If I wanted to print out numbers sub 0, the first element of the array, I would write something like this. So cout is the standard output stream in C++, and the reverse of that is cin. And so if I wanted to get some input, I would use cin and these two greater than symbols, and then we could do something like this. So this would get user input for the first element of our array. And this operator right here is called the extraction operator. So we write that out here. This is called the extraction operator, and we looked at this in the Hello World video, where this operator is the insertion operator. We can insert something into the input stream, or we can extract something from the, or excuse me, I should say, we can insert something into the output stream, or we can extract something from the input stream, right? So we're not going to worry so much about the output right here. We're just going to worry about input. Now, if I wanted to get input for more than one value here, we could just copy and paste this and write out something like this. This would absolutely work, but this is not a great way to do this, because what if the size of this array wasn't 3? What if this was 10? What if this was 1,000? We definitely don't want to copy and paste this code over and over and over again and just change all of these numbers from 1 to 999, right? So that's not a good approach. We should definitely use something like a loop. So for loops in C++ are similar to for loops in just about every language. We start out with the word for, of course, and then we're going to put some initialization in here. So I'm just going to use a simple integer. We'll call it I for index. This is pretty standard across just about every language, and we'll initialize it to 0. Then we'll say as long as I is less than, let's say 3, and I++. Also, I should change the name of this, or the size of this array back from 1,000 to 3. So this loop here is going to run 3 times. It's going to start at 0, and then run as long as I is less than 3. So when it's 1, the loop will still iterate. When it's 2, the loop will still iterate. And then when I++ turns that to 3, that condition will fail and will no longer execute this loop. So then I'll just get some simple user input here into numbers sub I. Right? So the first time this loop runs, we'll hit number sub 0, then number sub 1, then number sub 2, and then we're all set. Now, if we are writing a loop, much like a function, we'll have our loops encapsulated with these braces here, and that's all fine and good. If we only have a single line in our loop, we don't need those braces. But if we happen to have, let's say, 2 lines in here, then we would definitely need those. Otherwise, one of these lines would be inside the loop and one would be outside, which could be a little bit disastrous to our program functionality. That's what we really needed. Now, if you're coming from something like a Python background, what we really needed. Now, if you're coming from something like a Python background, then this is a clear indicator that these 2 lines belong to this loop because they're tabbed over, but that's not how C++ and many other languages work. So we'll need to be careful of that, but we'll see plenty of examples of that in the future, so don't worry about that right now. So here we get some user input for this, and we can just write a simple comment to get input for all of the numbers in our array. Okay. So if we just wanted to do, a simple test to make sure that we've actually got these values correct, let's say I just copy and paste this, and we flip this around and say, cout, and we could do something like a value from the array would be something like this, and we'll do an end else statement. So if I want to run this now, I can just come up here and run it using this option here, or we can go to debug, and we're going to run without debugging because I don't actually need to debug any of this. This code should work just fine. So when this pops up, our program runs, and it's sitting here just waiting for me. It's waiting at this cin statement. It's waiting for me to Type a number. So if I just type in any number, let's say we'll do 10, it's waiting for me to type in another number because this array runs 3 times. So I type in 42 and 17, then it prints out the 3 values that I had right there. And of course, as we had seen in the previous video, it'll print this out automatically. That's something that my IDE Visual Studio will sort of add into the program execution. We don't need to worry about that, but that's what our program is printing out right there. So that's all fine and good. We don't really need to actually print this out, but if we wanted to, that's how we could do it. So now let's say the second part of our task here was to check and see if the sum of these numbers is positive or negative. Let's actually get the sum. So in order to do that, we can make another variable to store all of that. So let's just say we'll do int sum equals 0. And in C++, it's very important that we initialize our variables. By default, in C++, variables don't get a value. They are just considered uninitialized. Right? So this is an uninitialized variable that has a value of I don't know what. If we were to print out this value, who knows what it's going to give us, right? It's just an uninitialized value, which if I try and print that out, and we do something like this, then we're just going to get some random value. In fact, I won't even be able to build it in this case because many compilers will detect that you've never initialized something and it'll simply generate an error. If it did run, it would give us a bogus value. So it's very important in C++ that you initialize your variables to some reasonable value or to some sensible value. So, a suggestion here, initialize to sensible value, whatever that actually means for your program. Now, very commonly with numbers, we initialize them to 0 because in the absence of any other information, 0 is a pretty good assumption. If you arbitrarily picked 3 or 10 or whatever else, that might be okay in some circumstances, but in the absence of any specific number, 0 is really a good choice. So if we initialize this to 0, then what I'm going to do is add everything up. So I need to, again, iterate through my array here. So for int I equals 0, and I could just copy and paste that, of course, but I'll just type this out so we can see it again. And then I'm going to say my sum plus equals numbers sub I, right? And again, we could write our loop something like this if we wanted to. You might see some people write for loops like this. Some people might prefer this style where they always have braces around all of their loops, even if it's only one line. I personally don't prefer that style. I would rather eliminate the braces if they don't need to be there, but everybody's got a personal preference, and it's really okay when way or another. So we can add up all of those values here, and then at the end of all of that, the last part of our task was check to see if the sum is positive or negative. So we could do something as simple as if our sum is greater than or equal to 0. Now, we could sort of debate whether 0 is a positive or negative number. Some people lean one way or another. We could, let's say we don't even want to get into that argument and debate that at all, and just say, you know what, let's not even worry about that right now. So let's say if it's greater than 0, we can do cout number, or just sum rather, is positive. And we'll print out, oops, that's the wrong key there. And after that, we can say else if the sum is less than 0. Then we can say sum is negative, sum typed properly. And then finally, we could do something like an else, because if we have, a variety of conditions, the else statement is in all other cases that we haven't accounted for, which in this case, the only possibility would be if sum is exactly equal to 0. So we could do something like this and then just say cout sum is 0. Okay. And so remember the endl statement here, that's just going to print out a new line character. If we took this out here, it wouldn't necessarily be a terrible thing because this is the end of our program. But if we had any other kind of output, we might not want to see it all jumbled together, just one output immediately after another. So if we were to run this again, and also a note about braces again, with if statements, else statements, it's the same convention as for loops. So we could wrap them in braces, and if we had more than one line, we would definitely need to wrap these in braces to say all of this is the if statement, or the code underneath this if condition. If it were true, we would need these braces here. Definitely need to wrap these in braces to. But if we only have one of these lines, then we can just omit them, which I will typically do. I don't really like to just see those unnecessary braces, but again, to each their own. So if we were to run our program now, and we do the same thing, we enter in 3 values because that's what we need to do right here. Let's say we just do 10 and 20 and negative 50, then the sum is negative because of course it is. We have a sum of negative 20 with the these three values here, right? So that's pretty much our task accomplished. And, there's not a whole lot of code here. This is all pretty straightforward stuff. But what if we wanted to simplify some of this? Or what if we wanted to move some of this code around and do things a little bit differently? What if we wanted to move some of this code into functions? Because as we write code in main, and main tends to grow and grow and grow, it gets longer and longer, and we start scrolling and scrolling. One single function could be filled with hundreds of lines of code. We want to split that into smaller pieces. It just makes it easier for us to understand if we break it into smaller pieces. And so let's say we maybe want to do something like this here and get the sum of all of this and handle this sort of thing in a function. So that way we don't have to execute all of this code right here, but instead we'll just call a function that does all of this. So let's say we write a function and we're going to return the sum. So we'll return an integer and we'll just call this something like get numbers. And And so inside this function, we're basically going to do all of this right here. So I'm just going to cut that, paste that up there. And I'm going to need my sum variable to be sent back. Also, I forgot to take the array itself. There we go. And then we'll return sum at the end of this. So now down here, we've still got the issue of the sum not really showing up in this case. So we might do something like sum equals get numbers. And then we can do this check down here. Now, if we wanted to also take this code and put it into a function, we could do that if we wanted to. So let's say we make another function and we'll just call this void positive or negative. And we'll take in some value. So all of this code right here I can just copy and paste that in there. So now we run into the issue here where I called my parameter value, but the variable from my other code was called sum. So I have a choice here. I can just change this to value if I wanted to, or I could just change the parameter to be sum. Either way is fine, whatever you prefer. So now I would have to call this function down here, and we can call the positive or negative function. And pass it our sum variable, right? So now our code is doing the same thing really that it did before. We're getting some numeric input. We're then checking to see if the result of this is positive or negative. But as far as main is concerned, this looks a lot slimmer. This looks like it's doing a little bit less, or at the very least, it's less cluttered. So now we can kind of highlight the key points of this operation is step one, getting this user input, and then step two, checking to see if the sum is positive or negative. And it's really just doing 2 steps. Now, of course, each of these steps is a little bit more complicated than just one operation. We've got a lot of code up here. We've got a lot of code right here, but still main is just these 2 steps. So this process right here, this is a very simple example, but this concept, you should really, really try to embrace this. And it takes time and practice to get used to this sort of stuff. But when you're writing code, think about the ways that you might move code into functions. Think about the ways that you can simplify some of your code to make it a little bit easier to read, a little bit easier to understand, and that can help you write other code in your programs more easily. Because a lot of times when we write new code, we have to understand the existing code first. And this is pretty easy to understand because it's 2 steps. Now, if anything needed to change, if we needed to make any sort of fixes inside this particular function, or make any additions to it, or change these steps here, we can certainly go and make these modifications up here. But as far as main is concerned, if I need to add anything to main, there's just these 2 lines of code that I have to contend with, right? And also, many IDEs have this feature where they offer outlining of your code. So I can just collapse these 2 functions here. And this can be nice because it gets it out of the way. I don't have to look at that code anymore. Assuming it works, assuming it's done, I can just sort of push it off to the side a little. And then I can focus just on whatever it is I'm trying to do here without having to look at all of my code all of the time, because that can be distracting. That can be sometimes confusing. That can, make things more difficult for us than it really needs to be. So if you have a feature like this, I highly suggest you try it out at the very least. I've been writing code for a long time and haven't always had IDEs with this feature, but once I started making use of it, it's hard to go back really. I like to minimize as much of my code as I can. So something else to keep in mind, we have all of our code, all of our functions here above main, and this is a style that you might see. You might see this in a lot of different locations, but another style that you might see, and one that we'll talk about and see pretty extensively throughout the course, because this is the way that I tend to write my code, is taking these functions and putting them below main and writing what are called prototypes for these functions. So if I were to take these functions here and move them below main, now, again, this is a way that we can kind of take some of our functionality and hide it a little bit. We're sort of sweeping it under the rug a bit, so we can just kind of focus on this stuff up here. But when I build my code, so we come up here and just say build this particular program here, we'll get a couple of errors. So the get numbers function is not found. This identifier is not found. Likewise, this positive or negative identifier is not found. So my compiler is just looking at this, and our compiler goes from top to bottom. So nowhere in this code up here does it see anything named get numbers. Now, we can look at this as human beings and just point to it right here. There it is. How do you not know where it is? But remember, we're dealing with computers here. So it starts at the top, doesn't find get numbers, and then it's a compiler error. It doesn't know what this is. So what we could do to solve that is we can take this code and we can write a prototype for it. Now, if all of this were above main, then we wouldn't have to worry about it because get numbers is located right here. But the reason why we might use these prototypes is, let me take this and put this back up here. Now, let's say for some reason inside this function, maybe I return the sum, but also in this function I call the positive or negative function. Now, if I were to build my program here, I'm going to get that error that we saw previously. If I come up here and build this, we'll get this positive or negative identifier not found error right here because this function doesn't exist anywhere up here because it's declared below it. So I could again take my code and just move it up here, but we really don't want to do that in our code. Programming is hard enough as it is, and having to worry about the order of our functions and shuffle that order around every time we write a new function that somehow throws off the order of things, this is really not a great way to write code. So what we can do instead is create function prototypes. So what I'm going to do is take this and put these back down here underneath main. And so what we can do is just take these function, what are called function headers, and just copy this and paste this, put a semicolon at the end of it. So now this exists as what's called a declaration of our function. So this prototype, this declaration, exists to let our compiler know, hey, this is an identifier. If anybody tries to use something called positive or negative, or if anybody tries to use something called get numbers, it's okay, let them do it. So now when our compiler hits this line, it sees this and says, oh, I know what that is. That's fine. When it sees positive or negative, it says, oh, I know what that is because I've seen this previously. We don't need to worry about the definition. That's handled in something else. That's handled by the linker of our build step or our build process. So this just lets all of the functions know about all of these identifiers. So now the order of everything doesn't really matter. If I take this function here and move it up above positive or negative, it's fine because this positive or negative exists up here as a prototype. So it's a good idea to get into the habit of writing prototypes, especially because when we start looking at classes, we will use prototypes pretty extensively because classes will have prototypes written in them, but we'll get to classes at a later point in time. But still, it's a good idea to get into this habit because if we're in the habit now, later when we really need to do it, we're already doing it, and so we don't have to then worry about unlearning a couple of weeks worth of bad habits, right? And that's something that you'll just sort of have to trust me on this because eventually we'll get to the point where we really want to write our code in clean ways, even though the language doesn't make us do it. We can write really ugly, messy code, but the language just kind of allows it, even though it might not be very good for us. So along those lines, it might sometimes be helpful to develop sort of an organization for yourself up here. So up at the top, we only have this one include statement for IOStream. This is pretty common. You'll have IOStream included in probably every C++ program that you write. But it's a good idea to keep all of your include statements up in the same place. Like we have a whole bunch of these, and for large programs, we'll include things like vector, we'll include things like strings, and we'll have maps, and we'll have all kinds of include statements up here. It can be a good idea to well, we won't have the maps header file because that's not a thing, but we'll have the map header file. So it's a good idea to have some sort of organization up here. And what I tend to do is something sort of like this. You don't necessarily have to put these big comments in here, but I'll do something like include statements, and then finish that up right there. And then after that, what I'll do is put my function prototypes. And for main, we don't actually need a prototype of main. I don't have to do something like int main because no code should ever call main. You should have no code that actually calls the main function. Main is called for you automatically, so we never need to make any sort of declaration for this. So then we'll have main right here, and underneath all of that is where I'll put my function definitions, right? And so writing my code like this or writing your code like this, the way that I do, can sometimes be helpful, and you might come up with different organizational styles or preferences, and that's perfectly fine. But doing something like this to get started can be helpful. It can be good to, like I said, develop good habits, because going forward, when we start to write more complex programs, we want to be able to focus on solving the problem and not worry so much about how do I just type code? How do I just put code into a file that does anything? Because if we're wrestling with that, we can't really solve the problem that we're trying to solve because we keep wrestling with the tools that we have available to us, right? It's like using a hammer or a screwdriver. If you're struggling with the hammer itself, it's difficult to hit a nail into a wall because you're having a hard time even holding the hammer or whatever else, right? So that's about it for this video. We looked at just some basic functionality, writing a couple of In this video, we're going to take a look at Visual Studio and some of the basic functionality of this program. Visual Studio is an integrated development environment, or an IDE, and these are tools that combine text editors with compilers and debuggers, and basically they're your one-stop shop for writing. Get added in their own directories on our drive. So if we're curious as to where any of these actually are located, I can right-click on a project or on the solution, and at the bottom or near the bottom of this menu, go to Open Folder in File Explorer. And if I do that, then it pops up with the location of this particular thing. In this case, it was a solution. And so if we're looking at where we store this thing, it's in my code folder, and then I call it class assignments. So this is the solution location. We have this file called a .sln file. So here, this is the actual solution file. and in here is a solution. And so it pops up. It added in their own directories on our drive. So if we're curious as to where any of these actually are located, I can right click on a project or on the solution, and at the bottom or near the bottom of this menu, go to Open Folder in File Explorer. And if I do that, then it pops up with under the options, we can go to color scheme. Maybe it's I like it that way. And so if we wanted to, like I said, customize like the text, that's what one tiny, incredibly powerful and helpful to pop up the error list. We can move this around. We can dock this for header files. If you just click on a file here, it will show it in this sort of In this video, we're going to take a look at working with strings in C++. Strings can be a little difficult to work with at first, and just about every language has some form of string class that wraps around these difficulties and quirks and makes a nice, neat package. package for the programmer. In this video, we're going to take a look at working with strings in C++. Strings can be a little difficult to work with at first, and just about every language has some form of string class that wraps around these difficulties and quirks and makes a nice, neat package for the programmer to work with. C++ is no different in that regard, but before we get to that, let's take a look at what a string really is on a basic level. So we could say that a string is an array of characters, and that's pretty much it. But there is a little bit more to it. In kind of everyday conversation, that's okay to say a string is an array of characters, but it's slightly more nuanced. Now, oftentimes we want this array of characters to be something larger than itself. For example, here we have an array of characters that represents a name or some heroic concept. Here we have an array of characters that maybe represents a password of some sort. Here is an array of characters that represents a message. And so even though we're just dealing with a collection of little bits of data, we might group all those together into something that's more than just the sum of its parts. Now, we don't usually do this with other data types, right? If we had an array of numbers, and let's just say we had something simple like this, had 10, 5, and 15. If I look at this array of numbers, I really don't treat this as one entity. This is three separate elements. We have a 10, we have a 5, and we have a 15. We wouldn't say that this is 10,515. That would be a little bit strange. We're clearly separating these as different numbers. But here, we wouldn't take this string and say this is Batman. We would say this is Batman. And so strings are treated a little bit differently because of the way that we tend to use strings. We use them for names and words and so on and so forth. So let's look at what this string really is here. So if I put my mouse over this string here, we see that it says it's a constant character with an array of 7, but the string Batman only has 6 characters in it. So strings are a little bit different because it's not just an array of what we think it is, but there's also one additional character. So we'll look at some of these other examples here in just a little bit. But essentially, this array, or when I declare a string like this is writing what we call a string literal. When we actually write it out with double quotes, our compiler, when we build our program, is going to generate some code to essentially allocate some space in memory for exactly this data. And this is called a string literal. But this array here is essentially something like this, where we could say some array sub 7, but then if we tried to fill this out, some array sub 0 equals a particular character, and we'll fill all this in here in just a second. So we could say we start it with B, the A, well, that's lowercase, the T, the M, A, the N, oops, little typo there. And so then if I were to fill out the rest of this, we realize that we have sort of fallen short here. So we have 6 characters to spell out Batman, and yet when I put my mouse over this, it's a constant character of size 7. So really what we're missing here at the end is something called the null character. And so this character is a backslash followed by the character 0, or the digit 0. So even though this looks like 2 characters, really this is 1 character. And what this is called, backslash 0, is called null, N-U-L. The concept of null is something else, and oftentimes we'll use null as a stand-in for nothing or the absence of something else, and that actually has a concept in C++ as well. We'll talk about that later when we get to things like pointers. But this particular character is called null, N-U-L, and sometimes we refer to it as a null terminating character. It terminates a string. It indicates the end of a string. And so when we create something like a string literal, whatever we provided, Batman in this particular case, the compiler says, okay, great, I will make an array of characters with what you provided, and I will also add that null terminating character at the end. Now, this character is very important because when we try to print out a string, when we try to print this array of characters, what we're essentially seeing is a for loop, or the results of a for loop that is printing each character one at a time, as long as that character is not this null character. And so once that character is reached, we no longer print out that information, right? So that's the way strings work. They print characters one at a time until they find the null character and then stop. So if we didn't provide this null character and we tried to print out an array without it, we might get some strange results. And so this won't actually compile right here because I got rid of that variable. But if we tried to print this and we just print out some array and see what we get, we might get some strange results. And so here we're getting a bunch of junk, right? So I'm actually getting Batman printing out twice, even though I'm only printing out some array the one time. So we're getting a lot of weird stuff in here because essentially what's happening is my program is printing out characters one at a time until it hits a 0. And that's probably due to the way that this memory is organized on something called the stack. We'll talk about that later on in the course. Is it's printing out this data here, and then it's printing out a bunch of junk. Then it's printing out this and reaching the null terminator, which is right here at the end. So it's printing out my second example of Batman, a bunch of junk, and then the first example of Batman and a null terminating character. So if we don't have a terminating character, this is what we'll get, just random stuff. And we definitely don't want that. So if I were to put that null terminating character in here, and then we print this out, then we should just see Batman printed out once because it stopped at this null terminating character. All right. So fundamentally, that's what a string is. When we're talking about strings in programming languages, in just computing, it's really an array of characters terminated with a null character. Now, if we want to get into all kinds of string related operations, if we want to combine strings together and split strings and do all these kinds of operations, we need to always be worrying about this null terminating character. Every time we make a new string or split something, we always have to account for this. So, what I think of as an array of 6 characters is really an array of 7. So, if I wanted just 6 characters for Batman, this is not good. I really want that 6 plus 1 for the null terminating character, right? So we'll kind of revisit that concept here in just a little bit, but let's move on for right now. So we can also declare our strings as, you'll see this a lot in C++ code, as a constant character pointer. Constant, or const, the keyword stands for constant, something that we can't change. And character pointer, we'll again talk about pointers a little bit more later on, but essentially pointers are very similar to arrays. So if this is an array of characters, then a pointer, which also is an array, or arrays are pointers. They're not exactly, but that's close enough for now. This is another way that we may declare this. Also, when we're passing strings to functions, we may often see them passed around as this style here. So then lastly, this was just another example where we could use a character pointer instead of a const character pointer when I had another variable earlier, the password string there. So we'll just get rid of that. And then we'll look at this last example here. So this is an instance of what's called the string class. And we'll also talk about classes a little bit more. We'll start talking about that very soon. But for right now, we can go ahead and use this without really worrying too much about what a class is and all that other sort of stuff. So this string class takes all of that other functionality about null terminating characters and making sure that we account for all of those, and it essentially does it for us. So inside this class is all kinds of functionality to make sure that we can split strings, assign strings, copy data, handle a bunch of memory management, and all this sort of functionality for us, so we don't have to worry about that anymore. Now, it's not to say we don't need to learn how code works, because we have things like a string class. It can be very helpful to learn how code works to do all kinds of operations. But if we're going to use strings, it's often a good idea to use the built-in string class because it's just a little bit better. It's just easier to work with. And so the way that we use strings is we have to include a file in order to use them. So in some cases in an IDE that you're working with, you might not have to include some header files. They may sort of be automatically included for you. You should never rely on that though. You should always, always, always include the files that you need in order to use something according to the language, not according to some sort of boost or some help or assistance that your IDE has provided for you. So in order to use the string class, we need to include the string header file. So just pound include string. Now, if I wasn't already doing something like this, I would also have to do either using std string, or everywhere that I create an instance of the string class, std : string, like that. So now this is the string that belongs to the standard namespace. Personally, I prefer doing something like this, especially within the context of this class. It just makes it a little bit easier. In the grand scheme of things, we may want to be a little bit more careful with what we're bringing into our programs, but this is fine for now. So let's say we do something like this, and we'll just say Batman, because Batman is cool. So what can we do with a string? Now, Now, the string class has a lot of functionality in it. We can, if we just type name and then a period, we get all of these different options in here. Now, initially, this can be very overwhelming because the string has a ton of functionality in it, and we're not going to cover every single one of these. I'm sure there are a few functions in here that I've never needed to use ever in my programming experience, and that might be the case for you too, or maybe you end up using all of these someday. But we can access a lot of functionality. Whereas if we were making just a regular character array or a character pointer, if I did something like this, and let's just say we do, this is Robin over here, then Robin dot gives us nothing. We have access to nothing at all because this operator only applies to classes, and a constant character pointer or just a regular character pointer is not a class and has absolutely zero functionality. Sorry, Robin, you're not as cool as Batman. So let's get back to Batman here. Now, one thing that we could do on a basic level and a very common operation is figuring out the size of this. So earlier versions of, well, in C and C++ inherited this, there are ways to count the number of characters with a function called string length, or strlen is the way that it's abbreviated, but we can just use the size function of this class. So we could say number of characters in this particular string is just the size right here. So this will count up characters until it reaches that null character. So this would return a 6 or print out a 6 as return from this function because it counts up to and then stops at the null terminator. That's also true if we were to do something like this and put in a whole bunch of these null characters. Then this is an array of 14 characters that has all of this crazy stuff in it, but the size would count up until it stops right here. So null characters are interesting the way that they get used. So if we run this, then we'll see that it prints out just 6 characters, even though technically the string has a lot more. The way this function works is it stops on that. And really, there's no good reason to do something like this. Outside of, the sake of example. So we'll just get rid of that. Right. And so we can figure out the size of this thing. Now, if we wanted to, do any sort of like checking for characters in here, let's say, for example, we wanted to count some number of characters from this, like maybe count how many of the letter A there is in this simple operation here. But we could say 4, and I'm going to make an unsigned integer I equals 0. And the reason I'm making this an unsigned integer is because the size function of this returns an unsigned, not name.string, but name.size. There we go. This returns an unsigned variable. And also talking in typing at the same time can sometimes be a little bit difficult. So there we go. So I'm going to loop through all of these and just check and see if name, and I can use brackets here, and I can treat this just like an array. So technically a string is not an array. This string object, this class, is not an array, but it has a function implemented, specifically something called an operator that allows us to access this information as though it were an array. And we'll talk about that concept of operators and operator overloading a little bit later on down the road. But this will allow me to access an individual character one at a time and treat it just like it's an array. So it's a nice helper function. So if this is equal to the letter A, then we'll need to have some sort of count, which I don't actually have. So we can say int count, or we could call it total or whatever else. And then there we go. So then at the end of this function, we can say number of occurrences of A is the count, right? And there we go. So put a space in there. So we do that, and we should, if everything works correctly, we get the number 2, right? Now, something else that we might do with a string is combine things together. So if we had arrays of characters, if we did something like character name, well, name, other name, let's say we did Robin here. Now, in some languages, we can combine strings very easily. We might be able to do something like name plus the string and plus other name, and do something along these lines here. We can't really do this as easily in C++, although this is going to make me look kind of silly. We can kind of in this case because I'm starting out with a string. If this was something like this, this would not work out. So these are just regular arrays of characters. We can't add these things together. It doesn't make sense when we're dealing with these fundamental arrays to combine them in this way. And so working with strings, on the other hand, we can add that stuff together. Some languages this works out because of the way strings are handled by default in the language, or in some cases because everything in the language can ultimately be converted to a string. If you're coming from a Java background, that may be a familiar concept to you. So if we're starting with a string object like we have right here, then we might encounter some problems if we were trying to add this stuff together. Now, one way that we can do that, if we did want to somehow append some data to this, we can do this in a couple ways. So I could say name plus equals. There's the operator plus equals, where that will allow us to combine something to the original value. And I could say the word and then name plus equals Robin, and call it done. So now my string is Batman and Robin, which if I were to run this again, we added another A into it. So this would print out the number 3 because we've got an extra letter in there. You might sometimes see the same process repeated here with a function called append. So we might do name.append, and then we can append these same strings. We do something like this, and actually, let's say we just do that, and name.append. There we go. So these are two ways of doing the same exact thing. This is with overloaded operators. This is with an actual, well, operators are functions as well, but this is with a function that has the name to kind of be explicit as to what's happening. Like if you just looked at this, you might not know what that means. Adding a name and Robin. We might think that's a little bit unusual if we're not familiar with this concept already, but if you are familiar with the concept, then maybe it makes perfect sense. So we can combine strings together like that. To get both of those there, okay? So lots of stuff that we can do with strings in addition to this. If we wanted to compare strings, we can certainly do that. And this would just be as simple as we had, let's say, string, let's say something for a password, and it actually is password, which is a terrible password, by the way. Please don't have any of your passwords anywhere called just password, right? At least add a number to the end of it, and boom, super safe and secure. No one will ever guess that. So we had a couple of strings, and let's say, we compare them like this, which is a little awkward to type, super secure right there. But we can compare strings very easily, and this is the same as comparing any other data type. If password 1 is equal to password 2, then print out they're equal, otherwise they're not. You get the idea here, right? Else cout not equal. And so when we compare strings like this, it will compare the case of each of these letters, because really each of these letters is a number. There's a numeric value for each of these, and so the numeric value for lowercase p is not the same as the numeric value for uppercase p, and so these two strings would not be considered equal in this sort of case, right? Now, let's see what else could we do with strings. If we want to find things in a string, this can be helpful. There's a function that we can use simply called find, and that will return the location of something. So let's say, for example, get rid of all this stuff here. We've already looked at that example. Let's say we had a string, and we call this message equals hello world, right? So if I wanted to, I'm not printing that out here, we're just doing an example. And so if I wanted to, let's say, figure out where this comma was, if I wanted to figure out where that is. Now, I could do this manually. I could say int comma location equals, let's say 0 to start, and then go through everything here. So 0 is less than message dot size plus, and then we could say if message sub I is equal to a comma, then comma location, not command location, equals I wherever we happen to find the thing. And then I also want to break out of this. I want to stop searching. If we found the thing, there's really no need to keep looking. So I'm going to put braces around all of this here. All right. So we could do something like this to find a character, which is really not terribly difficult. Or if we wanted to do this or have this done for us, a function already exists to repeat this process. And so instead of all of that, we could simply say comma location equals, there I put an n in there again, that's a little unusual, but there's a function inside the string class called find. So we can call find. We can also call something like find first of or find last of. Find last of just counts backward, but find first of will count from the beginning and go in forward order as opposed to reverse order. So let's say I wanted to find the first of a comma. So this will find wherever that, and I didn't actually remove it earlier. It's the curse of the n here. And so this is going to return wherever it found that particular location. Now, if it doesn't find it for some reason, so let's say, for example, we could print out comma is at comma location. But let's say we did another search. Search equals message dot find first of, there we go. And we were searching for the $sign. There's obviously not a $sign in this string anywhere, so we can skip that. Or we won't find one. There we go. So we won't find that particular character in there. Now, what's going to happen? What value is this going to get, right? Now, normally what we should do is when we catch the result of this function, we should catch this in an unsigned integer. That's the appropriate data type for this, because we can't have a negative index, right? We can't find something at -1 or -2. Also, the return of this, if it fails, is a very large number, which is essentially the result of setting this to -1. And so what we can do is say if search is equal to, and in the string class, there's something called npos, NPOS. And this is essentially, I didn't find that thing. So if the result of the search is equal to npos, then we could say cout couldn't find the $sign. Right. So if we run this now, then we should see the commas at a particular location, and we couldn't find the dollar sign. Right? Now, we don't necessarily have to catch this in a return type at all. We could just do something like this here. Right? Now, we don't necessarily have to catch this in a return type at all. We could just do something like this here. And if we're only looking to see, does it have this at all, not necessarily we need to track where it is or I need to store where it is, then this can work as well, right? So something else that we can do with strings is split them, right? Splitting a string can be very helpful. For example, let's say we've got hello world right here, and we want to split that. Maybe we want to split it into two words based on this location right here. So I can find that, which we actually had just a second ago. Let's bring that back real quick. So I found where it is, and then what I could do is use a function called substring. So sub str, and this will return a new string from some portion of the original. So I would do something like message.substring, and I have two values here that I give it. The first is some offset, where to start. And the second parameter is some count, or how many characters, with spaces. So how many characters do we actually want to copy into this substring? So let's do a quick example. We could also do this with a string that says Batman and Robin. We could split that up as well. But let's say we're starting with the message here, and we can say string first half equals message.substring, and I'm going to start at the beginning, and I'm going to count the number of characters based on whatever this size is. So we can say comma location, and there we go. So if this is at location 5, then I'm going to copy 5 characters, which will be 1, 2, 3,